Okay, we are going to continue on with our differentiation rules. So we're going to add pretty much a new rule in every lecture for a couple of days. So this is just one more. So we already know the power rule. We know the constant multiplier rule as well. And so now we're going to add to it the sum and difference rule. And so basically the rule is that if I have f of x plus g of x, and I'm assuming here that f and g are both differentiable, right, my little side note over here, is equal to f prime plus g prime of x. So I'm going to run through just a really quick proof of this. So the way that we prove anything is we show, right, so if my new function is f plus g of x, then I'm going to have f of x plus h. I'm using the differentiation, or my limit definition of the derivative, plus g of x plus h, right? So this is it's essentially my f of x plus h here, and I have minus f of x plus g of x. So I'm just using, right, I'm using this with my limit formula over h. Okay, so now I'm going to move around some parentheses here. I have a limit as h approaches 0 of f of x plus h plus g of x plus h. I'm going to distribute my minus sign here, get minus f of x, and then minus g of x over h. And then my last thing, I'm just going to move some things around. Okay, so I'm going to have the limit as h approaches 0 of, so I'm going to put the two f terms together and the two g terms together. So I have f of x plus h, and then minus f of x, and then I have plus g of x plus h minus g of x. So all I did was change the order in which I wrote everything. Now my last step, I'm going to break into two. When I have one thing in the denominator, I'm allowed to break into different fractions. So I'm going to put these two over h and these two over h. So I have limit as h approaches 0 of f of x plus h minus f of x over h plus f, or actually g of x plus h minus g of x over h. So this limit applies to both of these. Now that I have two pieces, I should put a bracket. And so now I'm going to break these two limits apart. So I have the limit as h approaches 0 of f of x plus h minus f of x over h plus the limit as h approaches 0 of g of x plus h minus g of x over h. And this is exactly the definition of f prime. So this is f prime of x, and this is the derivative of g. Right? That's the literal definition of what it means for it to be f prime. And this is the literal definition of what this means to be g prime. Okay, so we have another new rule for us. Now this is wonderful because it allows us, right, in the previous lecture we could only do the derivative of things that only contained one term. And so now that we can take the derivative of these individual pieces, so it's like each one of these terms is a different function. So like this is f, this is g, this is h, this is I. So I can take the derivative of a function with more than one term. So it just means I can look at each one separately and do its own separate derivatives. So I'm just going to apply my product rules in each one, or not my product rule, but my my power rule in this case. Okay, so this I'm getting a little bit faster at these. Okay, so I'm not going to write maybe every step. If you need to, then you do it. But this will be 4x cubed, right? This is the derivative of x to the fourth, plus 2 times 3 is 6x squared, plus, then this is our special case, this is 6, the derivative of negative 4 is 0, so we don't write it. So I have my f prime. It makes it so much simpler. Now in this g, I might want to rewrite this just to make it really clear that this is negative 1/3 x to the fourth plus 2x cubed minus 4x. And I'm ready to do my g prime of x. So this would be negative 1/3 times 4, so I'm going to write negative 4/3 x cubed plus 2 times 3 is 6x to the 1 less power 2 minus 4, right? The ones with the plain x just get dropped off. Technically is a power here of 1, but 1 minus 1 is 0, and anything to the 0 power is 1, so the x just goes away. All right, so h I need to rewrite here a little bit before I get started here, because I know in order to use my power rule, I need to write this as a power. So I'm going to just rewrite h as 3x to the, it's the square root of x, so that's a half, and it's in the denominator. I want to pull it up. That gives me negative a half, plus 2x to the 3 halves minus 4x. Now I'm ready to do h prime of x, which will be 3 times negative a half is my first thing, so I get negative 3 halves, x to the minus 3 halves, because negative 1 half minus another 1 is negative 3 halves. Then I'm going to have plus 2 times, I'll write this one, 3 halves, x to the 1 half, and then minus 4 is my last thing. So let me just clean this one term up a little bit. So I have negative 3 halves, x to the negative 3 halves, and then the 2 times 3 halves gives me really 6 halves, which is just 3, x to the 1 half minus 4. All right? So the power rule and now this sum and difference rule really allows us to do these at a much higher rate of speed. So I have a couple of more problems that we can actually do the same way, but they just require a little bit extra algebra. That's it. So this is x cubed minus x to the 1 half plus 3x to the 2, this is supposed to be 2/3, let me just rewrite that, over x. So this is before I can use it, right? The only thing that I have at my disposal right now is my power rule, and so I need to write each one of these with a power, but right now I have division, okay? So I need to get rid of this division. So when I have one thing in the denominator like this, I can write each one of these things as a separate term over it. So I'm going to rewrite m as x cubed over x minus x to the 1 half over x plus 3x to the 2/3 over x. And now I'm going to simplify each one of these. Right? So when I'm dividing, it's like I'm subtracting the powers, right? So let me write this as implied 1, right? So I have 3x cubed, I have x cubed, so when I divide by x, I'm left with x squared, 3 minus 1, and then the sign stays the same. I have x to the 1 half over x to the first, so I have 1 half minus 1, giving me x to the negative 1 half, and then I have plus 3x to the 2/3 minus 1, which is negative 1/3. So this is my rewrite, and now I'm ready for my derivative. I have m prime is 2x minus, actually this is going to be minus negative a half, so I'm going to write plus a half x to the negative 3 halves. Then I'm going to have minus 3 times, because this is going to be plus times minus, so I'm going to end up with minus a third times 3 is 1, so I just get x to the negative 4/3. And then my last derivative that I wanted to find is n of x. Okay, so this one has a giant exponent on it, and I don't have any rules for that. And so what I'm going to have to do first is do some algebra to expand this. Right, so this is my derivative up here for the previous one. So when I expand this, I'm going to rewrite it like this instead. Okay, so this will be 4x squared minus 12x plus 9. So my n prime of x is equal to 8x minus 12. All right, so hopefully we get good of those. You might need to practice them a little bit, but I did want to talk about one application of the derivative, a really common one that we use a lot. So first of all, a position function, and we usually call them s, gives the position of an object relative to the origin as a function of time, s of t. And so the rate of change, right, if we think of the slope, it would be the change in s, right, over the change in time. So because t is really our x, so this is like y over x is our slope. So in this case, it's the change in height or position over the change in time. And so the change in distance over the change in time. And so this is actually the instantaneous rate of change is really the derivative of the position function, which we call s prime. So sometimes we relabel s prime to be v of t. V of t is the derivative of the position function, and it tells us the velocity of our function at any point in time. We can just figure that out. So first of all, velocity is considered speed plus direction. So we can have a negative direction. That's the speed, and then negative direction means it's going down. So when we're talking about x with directions, then right is positive and left is negative. If we're talking about y, then going upward is positive and downward is negative. Okay. So let's do an example where we need the velocity of something. All right, so we have a word problem here that says a diver is jumping from a platform, and we're going to assume this is at time 0. We're starting the clock now. He is on a diving board that is 32 feet above the water. The position of the diver is given by s of t. Okay, so this is our function that describes where the diver is in position after he jumps off the board that's 32 feet above the water. Okay, so, and then s is measured in feet, so that's the height of the diver in position from the water, and then t is in seconds. So we want to know, when does the diver hit the water? Okay, so we don't need calculus for this part. So if I think of my xy here, then I have t is time and h is height. Right, so this is how every ordered pair is on it. T is the time and h is the height at that time. Okay, so when does the diver hit the water? Well, he hits the water when he has a height of 0, right? Because the pool would be 0. So I'm just solving a basic quadratic here. Right, so no really calculus is required right now. So I know this is a quadratic that I want to factor, and I'm seeing common 16s everywhere. So I'm going to factor out a negative 16. That'll give me t squared minus t minus 2 equals 0. I can factor this to t minus 2 times t plus 1 is equal to 0. Now, I do have the negative 16 still sitting up here, but when I set these equal to 0, negative 16 can't be equal to 0, so I could just easily have divided away. So this gives me t is 2 and t is negative 1. Now, in this context, since we started at t is 0, t as negative 1 doesn't make sense in the context of our problem. So he is going to hit this tells us he's going to hit the water at 2 seconds after he leaves the platform, right? So he's going to hit the water quite quickly. And so now we want to know, what is the velocity on impact? Well, first of all, we need a velocity, something to tell us what the velocity is. And then we know that his impact is 2 seconds after he leaves. So what we're actually looking at is v of 2 is what we want, or we could write it as s prime of 2 as well, because the derivative of the position function is the same thing as the velocity. All right, so we'll come back up here and we'll use s, right? So here's s. So I'm good. So s prime of t, or v of t, is equal to, I'm just going to use this one up here because you can see that one, negative 32t plus 16. So this is my velocity function. I want specifically the velocity at time is 2, and so v of 2 gives me negative 32 times 2 plus 16. So this gives me negative 64 plus 16, which tells me I'm going to get negative 48. Okay, so this is in y over x, right? So this means it's in feet per second. So negative 48 is the feet per second is the speed that he's traveling, and then the negative piece means that he is, right, the platform is up here, the water is down here, so he is going downward, so this is the direction that he is traveling. So he's traveling at this speed. We can often talk about the speed being the absolute value of the velocity. And so he's traveling at a rate of 48 feet per second. The negative sign is an indication that he's traveling downward, which makes sense since there's gravity.